Figure shows the velocity graph of a 69 kg passenger in an elevator. What is passenger's apparent weight at t is equal to 1 second, and at t is equal to 5 seconds, and at t is equal to 9 seconds? This is the question. Now the graph is given to us. This is based on the Newton's laws. Okay, Newton's second law. Actually, here we have the two types of forces acting on the passenger. One is the weight acting downwards, and then the apparent weight upwards. Here I show you. Let us consider this be the elevator, and then this is the weighing scale, and then the passenger is standing like this. Okay, and then here, as per the graph, this is the velocity versus time graph. So in the first half, first 2 seconds are actually first 2 seconds, as per the graph, the elevator is accelerating upwards, and then afterwards maybe it is stationary, and then later it is coming down. That means accelerating downwards. Now we have to take the call. Okay, so what are the forces acting on the passenger? Here, two types of forces acting in. So weight is acting downwards. This is the Fg. And then obviously Fn acts upwards. Am I right? So this is Fn, normal force. Now in the first 2 seconds, the elevator is going up, accelerating up. Acceleration is in this direction as per the graph, because this is the velocity versus time graph. Now in the first second, when t is equal to 1 second, we have to find out the acceleration. First, before that, let me write the equation. We know F is equal to ma, Newton's second law. And then here sigma F means net force. Net force is Fn minus Fg. So Fn minus Fg is equal to ma. And we know Fg is equal to mg. Therefore, Fn is equal to mg plus ma, or Fn is equal to mg plus a. This means this Fn is the apparent weight. Apparent weight is Fn. Okay. Now, in the first case, we have to, G we know, G is equal to 9.8 meters per second square, we know. But A we have to find out from the graph. So when t is equal to 1 second, we have to take the slope. So acceleration is equal to rise over run, velocity over time. Okay, here the velocity is 4 meters per second when t is equal to 1 second. So I'm taking 4 by 1 is equal to 4 meters per second square as the acceleration. I calculated the acceleration from the graph. Now substitute this value in this equation. Fn is equal to mg plus a. Now when we substitute m is equal to 69 kilograms, and then g is equal to 9.8 and a is equal to 4 meters per second square, we get the value 952.2 newtons as the apparent weight. Okay, when the elevator is accelerating upwards. That means when time t is equal to 1 second, the apparent weight of the passenger is 952.2 newtons. Next, when t is equal to 5 seconds, when t is equal to 5 seconds, here from the graph we see that the velocity remains same. So there is no change in the velocity. The line is parallel to the x-axis. Okay, so when the line is parallel to the x-axis, the slope is equal to 0. Okay, no slope, no. Therefore, acceleration is equal to 0. Here we have to take rise over run. There is no rise at all. Therefore, a is equal to 0. When a is equal to 0, this is equal to 69 into 9.8. We get 676.2 newtons. This is the apparent weight when t is equal to 5 seconds. Next, when t is equal to 9 seconds, what is happening? From this graph, we see that the elevator is coming down. So here again, we have to take the rise over run. So rise over run, what is the here rise? Here rise is almost 4 meters per second, because this is, I copy pasted. So the graph is not exactly same. Okay, there is some difference in copy pasting the capturing the image. While taking the screenshot, the dimensions will not be the same. So here, so for 9 seconds, it is almost 4. Okay, and then here you take the rise over run. This is the rise over run. Run is here 1 second. Am I right? The rise is the negative slope. Here it is the negative slope. Am I right? The object is coming down, and this is the line. Okay, so here in this case, this is the line. Am I right? So when this is the case, the slope is negative. So acceleration is equal to minus 4 by 1. Okay, so minus 4 meters per second square. Substitute this value here. A is equal to minus 4. You get the value 400.2 newtons. This is the answer for this question. Here you are finding the apparent weight, means you are finding the normal force. Okay. G acts downwards, normal force acts upwards. And here you have to find out from the graph, you have to find out the acceleration. If you know how to read the graph, then you can easily solve this problem. Okay. Hope this helps. Thank you. Bye bye.